Suppose we have 2 points f sub 1 and f sub 2 on the plane, and we have a positive constant number such that the 2a is less than the distance between points f sub 1 and f sub 2. A hyperbola is the set of points P for which the difference of distances from those two fixed points is constant and equal to a. So we can write this, that d sub 1 minus d sub 2 in absolute value is equal to a. The points f sub 1 and f sub 2 are called foci for the hyperbola. Let's draw the line through the points f sub 1 and f sub 2, and let O be the midpoint of that segment f sub 1 and f sub 2. So the distance between the point O and the focus f sub 1 is going to be the same as the distance between that point O and the point f sub 2. The point O is called the center of the hyperbola. Let's draw another line, this time perpendicular to the line through f sub 1 and f sub 2 and passing through the point O. In similar way as we did it for ellipse, we can show that hyperbola is symmetric with respect to the line f sub 1, f sub 2, as well as with respect to that line that is perpendicular and going through the center. The line through the f sub 1 and f sub 2 is called the transverse axis for a hyperbola, and the line perpendicular to it through the center is called the conjugate axis. Because 2a is less than the distance between points f sub 1 and f sub 2, let's denote by v sub 1 and v sub 2 the points on that line through f sub 1 and f sub 2 in such a way that the distance between the center and point v sub 1 is a, and the distance between the center and v sub 2 is also a. So what we want is the points such that the distance between the center and the point v sub 1 is the same as the distance between the center and the point v sub 2, and we want this distance to be a. We can easily show that the points v sub 1 and v sub 2 are on the hyperbola simply by looking at the definition. If you look at the distance, for example, for the point v sub 1, of v sub 1 to the focus f sub 2, and subtract from here the distance between the vertex v sub 1 and the f sub 2, we'll get that this is the distance between v sub 1 and f sub 2, and because of the symmetry, the distance between v sub 1 and f sub 1 is the same as the distance between v sub 2 and f sub 2. And therefore, the difference of those distances is simply the distance between v sub 1 and v sub 2, and therefore it is 2a. So it satisfies the condition in the definition. In a similar way, we can show that v sub 2 is also on a hyperbola, and the points v sub 1 and v sub 2 are called the vertices for this hyperbola. Now, if I were to draw the set of the points, again using the symmetry, I know that v1 is on the graph of the hyperbola. The graph of the hyperbola would take the following shape. So to summarize the properties, we can say that hyperbola consists of two branches. It is symmetric with respect to transverse axis and with respect to conjugate axis. Transverse axis passes through the center, vertices, and foci. So those points are on the same line. Conjugate axis is perpendicular to transverse axis and passes through the center of the hyperbola. The center is halfway between the vertices, and it's also halfway between the foci.